So this is exercise related to experimental techniques. Exercise 2. You can use the chat to state the answer, but I will answer most of these questions as this is just an overview of the topic. So state the name of the process that is used to separate oxygen from liquid air. So if you want to separate two miscible substances, because in a liquid air nitrogen and oxygen are mixed together, so how we can separate them? We can use fractional distillation. So the technique which is used to separate two or more miscible liquids or gases, that is known as fractional distillation. If you want to separate individual dyes in ink, so if you want to separate dyes, colors, food colors, amino acids, what we do, we use a technique that is known as chromatography. So chromatography is used to separate dyes or colors from each other. Question 3 is actually related to organic chemistry, so we will skip right now because that is not related to the topic. As in a chemistry, the topics are interrelated, but this part 3 is actually related to organic chemistry, and the answer is fermentation, but you don't have to answer right now this part as it is not part of separation techniques. Then part 4, obtaining water from aqueous sodium chloride. Aqueous sodium chloride means we need water from, so if we need water from salt solution, aqueous means dissolved salt is there in water and we need water only. So in that case we use simple distillation. So simple distillation is a technique to separate the liquid or water from the salt solution. And separating the precipitate form, precipitate means the solid. So if you want to separate the solid form when two solutions are mixed together. So to separate a solid when two solutions are there, they mix together, or to separate the solid from the liquid. So which technique we can use? We can use filtration. Is it clear? Question 1. Any doubt till now? So I'll move on to the another question. For part 3, you don't have to answer because that is related to organic chemistry. It can be evaporation, but why we do not write evaporation here? Uh, because this solid is already insoluble. So solid particles are there, they are not dissolved. So evaporation is normally used to separate the dissolved solid, and filtration is used to separate insoluble solid. That's why in the question it is a precipitate or a solid is there. So whenever you are separating a solid from the mixture, you use filtration, insoluble solid. If it is soluble, the difference between evaporation and filtration, Abdullah Sarfraz, when you have a salt solution, a dissolved salt, so you don't see a solid particles here. So as you don't see a solid particle, what you will do, you will supply the heat energy. So when you supply the heat energy, this water will evaporate. And as this water will evaporate, what you're left with, you're left with the salt which was dissolved, the salt appear. That is called evaporation. And in filtration, what happened? You already have a solid which is present. So a liquid, and you can clearly see the solid or a precipitate. So we want to remove this solid from the mixture. So what we can do, we can use filtration. So on the filter paper, the solid will left behind, and through the filter paper, the liquid will pass through. That is known as filtrate. So if you want to separate insoluble solid from the mixture, you use filtration. But if you want to separate soluble solid from the mixture, then you use evaporation or crystallization can be used. Is it clear, Abdullah Sarfraz? Yes, sign.
Sir, if the dyes are like separate already, and if
Hmm.
we do chromatography once again, will
Hmm.
that impact the results or something?
No, no, that will not have, like, once you are saying we separated the colors from each other and you are repeating it,
Yes, repeating it once again.
it will give the same result. Like example, say you have a sample of ink and you carried out chromatography, say it was a combination of red and green color, okay, so you are
Okay.
getting two spots. If you repeat the same procedure, and this time you're repeating with a separate red color and a green color using a same solvent, so red color
Okay,
will
sir.
rise to the same height and the green color will rise to that, so height will not change, they will rise to the same height if you
Okay.
repeat them.
Okay.
Is
Okay.
it
Thank
clear?
you. Yes, sir.
Okay. Yes, Abdullah Sarfraz, in the question they are insoluble. How you identify it is insoluble? As it is mentioned here, precipitate. The term precipitate is used for a solid substance which is formed by mixing two solutions. So when you mix two solutions, a solid is formed and you want to remove this solid. That is why you are using filtration. So the answer for the first one was the first one, oxygen from liquid air, that is fractional distillation. If you want to separate inks, dyes, or color, you use chromatography. Part 3 is not there, so leave that. Obtaining water from aqueous solution. If we need water from aqueous solution, like we have a salt solution, so we can use simple distillation. And if we want to separate the solid, the precipitate from the solution, so we can use filtration. Is it clear, question 1? Just a minute, I'll be back. So in question 2, starting with a sample of amino acid, how you separate and detect and identify the monomer. Monomer means small molecules. The term monomer means a small molecule. So starting with a sample of amino acid, describe how to separate, detect and identify monomers which it make of. Using your answer should include a method used to detect the monomers, how we can detect the monomers or small molecule which are present, and how to identify the monomer. So what we can do, if we want to identify, yeah, this can be done, Yusra, but because the separation technique, we have to mention a separation technique. So here, the technique which we will mention, we will use chromatography. Yeah, ion exchange chromatography or chromatography to separate and identify amino acids. And how it can be done? So practically how we carry out this, how to identify the types of the amino acids. So first what we will do, we will use chromatogram. The paper is called a chromatogram, and draw the origin with pencil. So I will draw at the same time. So what we did now, we took a chromatogram, this paper is called a chromatogram, and then we draw the origin with pencil. So this is the origin is drawn with pencil. Then place a sample of amino acids, because it is a mixture, and use suitable solvent. So we place a sample of amino acid. This is a position where we place the sample. But amino acids are colorless liquids, so it will not be visible to us. I'm just making a spot visible, but it will not be visible. So we place a sample here, then we use a suitable solvent. So any solvent in which amino acids are soluble, that is suitable, so we use that solvent. Then what happened? This chromatogram, as it will absorb the moisture or the solvent, so the solvent will rise on the chromatogram. As the solvent will rise, the amino acids will also rise with the solvent, but that will not be visible. Why it is not visible? Because amino acids are colorless liquids. So as amino acids are colorless liquids, what we will do? We will use locating agent to make spots of amino acids visible, or you can also say spray the chromatogram with a locating agent to make these amino acids visible. So when you spray this, what will happen? For example, if this was having two types of amino acids, so then you will see two different spots. If it was having three amino acids, then you will see three different spots. But as they did not specify here that how many number of amino acids, so you don't have to, it can be any number. You can make different number of spots just to show that it is a mixture of amino acid. And how we can identify the type of amino acid, or how we can know the amino acid, then we will measure the RF value for each amino acid to identify type of amino acid. Because approximately there are 20 types of amino acids. So how to identify which type of amino acid is there? For that purpose, you will measure the RF value. And what is the RF value? RF value is the distance moved by spot divided by distance moved by the solvent. So in a planning of experiment, you just have to mention, yeah, like there are no values which you have to state here. You just have to explain the idea that how you can detect the amino acid and how you can identify. So how we can detect how many amino acids are there? So using a chromatography, we can separate them and we can also identify. So first we draw the origin with pencil, place a drop of amino acid, mixture of amino acid, and then use a suitable solvent. And then after some time, spray the chromatogram with a locating agent, which will make these spots visible, and measure the RF value to find which amino acid is there. Because different types of amino acid, as there are 20 types, so each amino acid is having a different RF value. Is it clear, this experiment? To everyone? So whenever a question is there, identification of amino acid, you should always keep in mind that you have to use a locating agent, because these amino acids are colorless liquids. Moving on to the next question, question 3. In question 3, describe how to separate the following. In each example, give a description of a procedure, like how you will carry out that, and explain why this method works. So what is the reason why that specific method will work? Nitrogen from a mixture of nitrogen and oxygen. So when two or more gases are there, we also use fractional distillation. So the procedure or the method which we will use fractional distillation. And why this method will work, or how this method will, what is the reason why this method will work? Because oxygen and nitrogen have different boiling point. So as oxygen and nitrogen have a different boiling point, so we can separate them by using fractional distillation. Because fractional distillation based on the technique that if two or more miscible substances are there, they have different boiling point. The one which is having a lower boiling point will rise first, and the one which is having a higher boiling point will rise second. Is it clear how to separate the following? So the description of the procedure we use fraction distillation. And why this method work? Because two or more substances have different boiling point. If the same question was there, if they ask, we want to separate water and alcohol from each other. So if you want to separate water from alcohol, again the technique which we will use fractional distillation. Because two are miscible substances or miscible with different boiling point. So when two miscible substances, they have different boiling point, so we always use fractional distillation. Yes, Abdullah Sarfraz, you can use your mic. What's your question?
Sir, I did not understand question number 2.
Which one?
Question 2.
Okay, question 2. in the question starting with a sample of amino acids. So you have a sample of amino acids. Okay, means amino acids. There are many types, or 20 types of amino acids. So you have a sample is a mixture of amino acid. Describe how to separate, how we can separate the amino acid, how we can detect and identify the monomers like small molecules of amino acids. That is the question. Is the question clear now?
Yes.
A sample of amino acid means a sample is a mixture of amino acid, and you want to separate them and you want to detect and identify. So the first part, the method used to detect the monomer, how to detect these monomer, how you can identify that how many monomers are there, how many amino acids are present in the sample. So what we did, we use a chromatography, we draw the origin with pencil, we place a sample here. A sample is a mixture of amino acid or small molecules or monomer, we can say. Then when we use a suitable solvent, so the spot will rise. How many spots you see, that means, or that shows the number of the amino acids. Like if you see 3 spots, it means 3 amino acids are there. If you see 4 spots, it means 4 amino acids are there. Is it clear till now? The method to
Yes,
detect.
sir.
So
So
how
sir,
you
it
can
should
detect?
have 20
Yes.
points.
What?
It should have 20 spots.
No, no, not necessary, because in the question they did not mention a sample contain. They did not say a sample contain 20 amino acid. Maybe a sample contain 2 amino acids only. Maybe it contain 5 amino acids. We don't know. That is why you don't have to put 20 spots. You can put any number of spots here, just to show that it is a mixture. So it will have different spots. And then use a method to identify them. How to identify the amino acid? So what we can do, we can identify the type of amino acid by using RF value. Like there are 20 amino acids, and all 20 amino acids, they have different RF values. So using the RF value, or measure the RF value, we can identify the type of amino acids present. Is it clear now?
So we will check all the RF values of the 20 amino acids.
Yeah, but again, you don't have to mention all 20, because we don't know a sample. They did not mention this sample contained 20 amino acid. Maybe, example, this sample was having only 2 amino acids. So if it was having only 2 amino acids, so then what we will get, we will get only 2 spots. And how to know which amino acids are there? So what we do, we will measure the RF value, the distance moved by the spot divided by the distance moved by the solvent. So we may measure this RF value, and we will see the table for, because for 20 amino acid there is the full table. You don't have to learn the value for amino acid. So you can identify using the RF value, you can identify which amino acid was there in the sample. Is it clear?
Yes, sir.
Okay. If anyone is finding difficulty or you want me to repeat, feel free to say your doubts or ask your doubts, because during the test I will check your understanding level. So it's right now, this is a homework, so better clear your doubts. Yes, Abdullah.
So sir, there are 4 marks and we just wrote 2 points. Like
No,
use the
no, I didn't. I
chromatograph.
wrote all the points. If you check in the answer, I wrote all the points. I mentioned we will use chromatography, then how to carry out chromatography.
So these 2 points will not consider the same point or 1 point.
No, no. When you mention use chromatography, then you will mention draw the origin with pencil, then use a suitable solvent, then use a locating agent to make the spots visible, then measure the RF value. This will cover all the 4 marks. Okay, moving on to the next question, 3 part B. So again, there are different types of amino acids. So glycine from a mixture of 2 amino acid. So there are 2 amino acid, alanine and glycine, which is having glycine has a lower RF value. So we have, like I mentioned, there are 20 types of amino acids, but we have a mixture of 2 amino acid, and they mention one of them is having a lower RF value. So which procedure we can use? Saim, your question, is there a way where you don't have to use chromatography? In an amino acid, you use chromatography. It depends on the type of the substance, a mixture. So what procedure we will use? We will use chromatography. The term monomer means small molecule. This is a chemical term which is used for small molecule. Like a sample contains small molecules, so that's those small molecules are known as monomers. So we will use chromatography to separate these amino acids, and they mention glycine has a lower RF value. So when it is having a lower RF value, it means it is less soluble. So on what basis we separate the substances from each other? So different amino acids have different solubilities. So shows different RF value. The amino acid, yeah, they will move to different rates as well, and they will move to different levels as well. The amino acid with lower RF value is less soluble compared to amino acid with so amino acid with small RF value is less soluble as compared to amino acid with higher RF value. So which one is more soluble here? You have two amino acid. Which one is more soluble? Glycine or alanine? They give you the hint. Glycine has a lower RF value. So which is more soluble? So alanine is more soluble. So when we carry, we don't have to draw the figure here. We just have to mention, like, this is a chromatogram. We will draw the origin with pencil. Then we will use a suitable solvent. We will place a sample, and then we have to use a locating agent because amino acids are colorless. So we are because it's a mixture of two amino acids, so we'll get two spots. So which spot is for alanine, A or B? Which spot is representing alanine? B is representing alanine because B rises to a greater level. So the one which rises to a greater level, it means it is having a higher RF value as compared to the one which rises to a smaller value. Is it clear? Question 3 part B. Then magnesium sulfate from aqueous magnesium sulfate. So what is the meaning? The term I told you, when aqueous means it is soluble, like you have a solution. So if I have a solution, and that solution having a dissolved magnesium sulfate, but I want magnesium sulfate out from this. Because when a salt is soluble, you don't see a salt particles. You want to separate the salt out from this. So what you can use evaporation, or you can use crystallization. So evaporation or crystallization can be used to separate. And why this procedure will work? So you can mention evaporation or you can mention crystallization. And what is the reason why this procedure will work? Because the salt or solute is soluble. So when the solute is soluble, we can use evaporation or crystallization. Is it clear? Part A, B, and C. Then, yeah, for part B, chromatography mainly work for solubility, so it's better you use the term solubility. The technique is used to separate inks, colors, dyes, but what is the base of the technique? It based on the concept that different substances have different solubility, so they are separated from each other. Then a diagram shows operators used to separate the mixture of water which is having a boiling point 100 and ethanol which is having a boiling point 78. Complete the boxes to name the operators. So we already discussed, we call this as a fractionating column. Or fractionating tube, and below it is pointing on the stand, so that is a tripod stand, because it's pointing on the stand. Label the arrow in a condenser. So in a condenser, what happened? There is a cold water enter the condenser, because the water is used as a coolant. Water is having a tendency to absorb the heat. That's why, like in a car radiator, we add water. What is the purpose of adding water in the car radiator? Because water is having a greater capability to absorb heat energy. So it can absorb the heat energy from the engine, so engine will not be too warm. So a cold water enter this condenser, and hot water. So cold water is in, or you can also write water in, and hot water out, or you can say water out. Both labels are acceptable. The purpose of this water is to absorb the heat energy from the alcohol vapors, because what happened, you have a mixture of ethanol and water. So ethanol is 78 boiling point, so it will rise first. The red spot is representing ethanol. When it rises, this ethanol, so the water in the tube, the water in the condenser will absorb the heat energy, and it will convert this ethanol vapors into ethanol liquid. So what we collect will connect ethanol liquid here. You can say cold water out, that's also a right way. But normally what happens, when the water absorb heat energy, is not that cold, it become warm. So you can also say water in and water out. Identify one mistake in the apparatus. So what is the mistake in this apparatus? As you can see, a student is heating a distillate as well. He should not heat this part. So heating a distillate or heating of the collecting beaker, that's also right. So heating distillate or a collecting beaker, that is the right answer. Which liquid would collect first? So which liquid we collect first, and explain your answer. So we have alcohol, which is ethanol, and we have water. So ethanol will collect first, and what is the reason? Because it is having a low boiling point. So it is having low boiling point. It will vaporize first. Why would it be better to use electrical heater instead of Bunsen burner? So why electrical heater is suitable, not a Bunsen burner? So if I use a Bunsen burner, there's a risk involved. Bunsen burner may cause a fire. Ethanol is a flammable liquid. That's so you can mention ethanol is a flammable liquid. Or you can mention because ethanol is a flammable, so it can catch fire. Any one of them you can mention as an answer. Is it clear? And the last part, nickel sulfate contain water. So we want to remove water. So which technique we use? We use simple distillation. And you have to draw apparatus as well. Like you will have a flask, a bottom round bottom flask. Then you will have a condenser. It's the same apparatus we use instead of the only thing which is not there, because it is a separation, it is a simple technique, simple distillation. So in a simple distillation we do not use fractionating column, so we do not use this part. And we have a nickel sulfate which contain water. So when we supply heat energy, nickel sulfate which will left behind here, and water will evaporate, and it will condense, and what we collect, we will collect water in the other beaker. Is it clear? The second experiment, to collect the water from nickel sulfate. So technique which we will use simple distillation. And how we can test the check or presence of the water or pure water is there. You will write simple distillation and explain the procedure, and in your own words you will explain the procedure. You will mention, we'll supply heat energy, water will evaporate, then it will, condenser will remove heat energy, so water is collected on the in the beaker. And then most of the marks are for drawing. So you have to mention simple distillation, explain the procedure, and the marks are for drawing, as well as to check the presence of a water. You can check the boiling point, and it will boil at 100 degree centigrade. So this was exercise related to experimental technique. Any question?